This is Gabriel Custodiet of Watchman Privacy. I know why you're here. You're looking to escape the technocratic apparatuses that you see slowly enveloping you and restraining your freedom. For the fundamentals of privacy, you should start by visiting escapethetechnocracy.com to see my video tutorials, books, and other resources for getting off the surveillance grid. Watchman Privacy and Escape the Technocracy are leading the fight for privacy, and unlike just about any other show, we practice what we preach: private payment options, no threat modeling, no statist or collectivist solutions, and no sponsors, ever. You know what that means? It means we can speak the unmitigated truth as we see it. Your support alone determines the future of this show. Go support you and me at escapethetechnocracy.com. Welcome to the Watchman Privacy Podcast. Gabriel Custodiet here. I'm really pleased today to be joined by Emmanuel Maggiori. He's an author. He has worked and consulted with the tech industry and particularly with AI. I found him through his book, initially Siliconed: How the Tech Industry Solves Fake Problems, Hoards Idle Workers, and Makes Doomed Bets with Other People's Money. Great title. We're going to talk about that. He also has a book I discovered about AI. It's called Smart Until It's Dumb: Why Artificial Intelligence Keeps Making Epic Mistakes and Why the AI Bubble Will Burst. And then he also has a third book called Get Tech: Understand Computers, the Internet, and Cut Through the AI Hype, a crash course for non-techie entrepreneurs. So I've enjoyed these books. And Emmanuel, welcome to this show. How are you doing?
I'm good. Thank you. Thank you for having me.
My pleasure. Maybe just give a little bit more background about you, especially as it relates to these particular topics we'll be discussing today.
Yeah, well, I'm a software engineer in the first place. And then I did a PhD in AI. And I didn't want to work in the research field. So I just got a job, after the PhD. And unfortunately, I was quite disappointed, I would say, in the AI field. And this was early on, right? This is pre-ChatGPT. And I started saying, this is overhyped. People, they use AI because it's cool, because investors want to use AI. And I saw so many projects fail because of that, and if you see the title of my book, and it says why AI keeps making epic mistakes, right? These epic mistakes, they're called hallucinations now. That's the word people use. When I released the book, it was the beginning of ChatGPT, and the word hallucination was still not really very popular yet. But I was saying at that time, the way AI works now, it will keep making those really, really silly mistakes. We don't know how to fix them, right? And now it's a thing, hallucinations. So I started, I wanted to tell the world that AI wasn't all that cool, that, it was, sometimes there's a place for it, but it wasn't all that great. And so that was the story behind my first book, Smart Until It's Dumb. I was like, I need to tell the world that this is overhyped.
Yeah. So you have a background in this stuff. You've consulted. You certainly know what you're talking about, and I really appreciate the taking a little bit of air out of the bubble, because it is quite a bubble. And let's kind of start though with just tech generally, and let's just start with your Siliconed book, emphasis on the con, right? And then we can move on to AI. And it really resonated with me, your ideas, because I have been incredibly disappointed by technology in my life. Maybe that's my fault for not creating it, but the internet is cool. But in my view, nothing really that great has come out of the internet, right? Maybe cryptocurrencies, but those are a theoretical good years down the road, assuming people make the right choices, which they aren't. And almost all of that is pure scam anyway, and a waste of time. I look at the app stores on particular phones. Almost all of that, I think, is a complete waste of human capital. I think of things like Uber. For me, being a privacy person, trying to use Uber, it says, hey, we need your credit card. Okay, I give them burn a credit card, and it says, hey, we need your driver's license. It basically doesn't let me use the service. So I've just started using regular taxis again, which I started to prefer to Uber. Similar with Airbnb, they block a lot of people. So I'm just going back to hotels. Social media, I haven't used Facebook or Instagram in a long time. I find myself more social, more informed about the media. Peter Thiel has this good line. He said, we were promised flying cars and we got 140 characters. This is kind of partly what you're getting at in Silicon, but there's a lot more to explore. And I thought we could just use one of the first examples you use, and that is the example of this company called Juicero, which gets $120 million to develop a juicer that has disposable elements that cost like $5 to $7 per juicing. It's not a really good idea. no hope of being profitable, but it gets all this funding. And I wonder if you could maybe you just use this example to give people a little bit of behind the scenes of what happens in the world of startups, Silicon Valley, broadly speaking, tech companies, that something like that can happen.
Look, I've been very, very close to that world of entrepreneurship. I've worked with startups a lot. I've advised startups. I worked for startups. I've been in touch with lots of venture capitalists, and it always surprised me how really, if you want bad ideas, they get money, right? They get funding for things like Juicero. So we're talking of a juice pressing machine that would cost $700 to buy, right? But that didn't cover the cost of producing the machine, which was very fancy and it was Wi-Fi connected. And every capsule would cost $5 to $7. And you can see the flaw, right? It's pretty obvious nobody will ever want this, and investors, they compared it with Nespresso, but there were pretty obvious differences, and you kind of need some good technology to make coffee, right? You need high pressure. It's not the same for juice. So the company failed, right? But unfortunately, that's a comical example, but I've seen so many startups get funding for things that had obvious flaws, and nobody would talk about that, right? And I wanted to get to the bottom of it. That's one of the things I wanted to do through my research for that book. Why is this happening? And I like the story of Juicero because, these things are difficult to talk about because there's always an escape route for anyone who justifies that kind of investment, which is, well, you never know, for example, or nobody imagined that, I don't know, Airbnb would be such a thing, or you can always pivot. For example, Airbnb pivoted. Like initially the company was, supposed to do something else, and then they switched it up a little. So there's always, an exception or a way to justify those investments. Yeah, I just wanted to understand what was going on in the field because I've seen a lot of that. So I started doing research, speaking with VCs, with economists, with entrepreneurs to try to understand what was going on. How can you get $120 million from investors for something like that, like Juicero? But look, before we continue with this example or anything else, I want to go back to one thing you said before. You said a waste of human capital, and I wrote it down because otherwise I forget things. But I thought I wanted to go back to that point because I've had a few conversations lately with people who argue that bubbles are good. The internet, there was a bubble around the internet in the year 2000, but look at how optical fiber developed, or how many more places got access to an internet connection. And even now, we could say with AI, so many good things will be developed out of this bubble. So bubbles have, and there's even one more, WeWork. I've discussed the experience of WeWork in the past in my book. And one person told me, look, it is thanks to WeWork that we have different kinds of offices now, right? They're prettier, right? Offices are so cool. They've revolutionized an industry that was really old. And even though it was kind of obvious that WeWork would never work because it didn't make much sense from a business point of view, so many good things came out of it. Innovation needs this bubbly behavior. And that made me think, and one of my answers to that is that you should always consider opportunity cost. There are different courses of history, right? One is with WeWork and with Juicero. There's another course of history that we can't really know what would have happened, without Juicero, without WeWork. But there was human capital. So there were engineers that were working on building Juicero, and they were working on WeWork, right? So what would have those people done instead, right? So that's the part that you miss from the equation. You see the positive side of things. Yeah, well, Juicero could have worked, maybe, right? Or WeWork did a lot of good stuff for the real estate market. But then all this talent, all these people, what could have they done instead? Maybe someone would have worked on a new type of nuclear reactor, that would have been great, scientific or technological development, right? So we need to see both sides of the story when we look at the tech bubble, right? It's like, yeah, it's cool on one side, good things come out of it, but what about all this talent, working on all those things? Yeah, and that just popped into my mind when you said the waste of human capital.
Yeah, and look, I don't think that there's a lot of cheerleaders for a lot of these industries and all these sorts of things. And my thing is, I like to take a step back regularly and just analyze things and just make these harsh, sharp statements that I think are pretty useful at just saying, hey, no, this whole thing, we shouldn't have done that. What when you said that, I also think of, I remember talking to somebody who was studying was taking a class studying some really obscure language that didn't really help their career. And like nobody speaks this language. And I remember asking them, and I purposefully asked this question because I knew what they were going to say. I said, do you think this was worth it? And they said, oh, yeah. And, they justified it, right? Because they spent the time. So they justified it. And I just calculated and I thought, okay, so all the time in class, all the homework, you spent 250 hours, let's say, doing this. My question is, what could you have spent that 250 hours doing on something else? And when you phrase it like that, it becomes obvious like, oh, yeah, I could have been doing something else. Obviously, you'll justify what you're doing in the moment. There's money being thrown at you. You're going to you're logging in, you have the company logo on your chest, you're going to justify that on any given day. But the question is always, as you said, what's the opportunity cost? And one of the things behind this, Emmanuel, is the kind of the reason why a juicing company might get $120 million, whereas something like much more vital or crucial or less, let's say, technological, but still important for humanity doesn't, is a bizarre question. We have like the some of the reasons behind this, and you talk about them in your book. A lot of people might understand as well, like the free floating money, the low interest rates of the last decades, government grants, increased abstraction of like the stock market. I remember during the COVID era, Tesla, I think, had stock valuation more than the top 10 car companies combined. And meanwhile, it was producing like 1/10 of what Toyota was producing. So that was just this bizarre thing where it's like, what exactly does the stock market represent? So you also have weird things pertaining to VC funding, venture capitalist funding. You mentioned in your book, you said you're more likely to get funding for $1 million than 500,000 because somebody sees 500,000 asking for that as lacking ambition. So maybe you could just unpack some of the weird kind of financial stuff behind the scenes that allows these sorts of projects like Juicero or other things to exist when maybe they shouldn't.
And that's what I wanted to uncover with my book, right? When I was doing research, it was why has it happened, right? Because 2021 was the record year of VC in history. We're talking, there were 700 new unicorns, right? $1 billion companies. So to a day, basically, which is impossible, right? Like, I mean, it's inconceivable that it could be that many in one year. And it was very, very steep how investment went up that year, and then it collapsed in 2022, which is when everybody got fired too, right? Mass layoffs in the tech industry. And I wanted to know why. Why did this happen? And why does this happen so often, right? Because there seems to be a tendency. There was the dot-com bubble, and then there's always like the everything bubble in the technology industry. And a few things came up, one of them was how the VC industry operates itself, right? We're talking of lots of layers of managing other people's money, right? So for example, the public gives money to a pension fund, right? The pension fund will invest some of that money on venture capital, right? And then the venture capitalist will select startups, and they will give that money to startups. And a lot of people along the way, they make a commission from their investments, regardless of the result of that investment, right? So VCs, for example, they charge 2% a year management fee, right? Regardless of the success of the investment. And a lot of people, from within the field, they think, and they've told me that kind of causes a misalignment of incentives, right? Because you kind of want to invest as much as you can, right? Because that's how you make money. Yeah, the theory says they can make even more if the investment goes well. But, in practice, a lot of people have argued that this 2% commission has a lot of weight in the decisions they make, and that's why they raise more and more and more money. A lot of companies in the technology field, they sell their shares before being profitable, right? That's very common. And that means that you're kind of creating the impression of future profits or future growth, right? And people buy your shares based on that. That's also another thing, right? So hype has value for you, right? Because you sell your shares based on hype. It's almost like kind of greater fool kind of thing. So lots of things came up in that direction when I spoke with people. But then every once in a while, someone mentioned interest rates. And it came up a lot. And I didn't know much about economics at that point. So I wanted to learn. And I learned a lot about economics, like really hardcore economics. I bought lots of textbooks, and it's my new passion. But at that point, I wanted to understand, what does theory say about low interest rates? Could they cause a bubble? Could they cause an unsustainable boom, if you want? And the reality is that the ZERP era, right, the era of zero interest rates, it was on purpose designed to encourage risk taking. It's not me saying it. You can see official, explanations by the Bank of England, for example, saying
Right.
we want to encourage people to rebalance their portfolios, so they leave safe assets and they put their money on riskier assets like venture capital. Right. So this was engineered, to make people take risks. So because you can't make much of a return from safe assets, right? That's what quantitative easing was designed to do. So let's lower interest rates. Now you move away from those safe assets and put the money elsewhere. And that's what it was designed to do. And a lot of people mention that. I'm talking to people from inside funds who's like, oh, money is so cheap now. There's so much money flowing in, right? And the thing is that if you follow a very standard economic theory, this wouldn't tell you that there's any, if you want, silly behavior, because people are rational and they will think about their investments anyway, right? Some investments become more feasible, perhaps, but they're not going to do silly stuff with money because interest rates are lower. But other people don't quite agree with that. They think that lower interest rates do encourage some silly behavior, right? Some people have said, it's like they lowered interest rates to wipe out the problem of the 2008 crisis, which was itself caused partially by low interest rates. So it's like a never-ending, cycle of lowering rates to, encourage economic activity, but that can lead to some stupidity, right? And a lot of money, went into that field, the VC field. And I've heard a lot that low interest rates had a lot to do with that, right? If you think about it, it's even as if money was indirectly created out of the blue that ended up in the coffers of startups, right, to pay for the Juiceros of the world. And, I don't know what the truth is here, but I can tell you it came up a lot when I spoke with people involved, in making those decisions. And so, yeah, I think that there was a bit of that probably.
Yeah, absolutely. And you get these really bizarre things, like I was saying, the Tesla stock example, or you have companies, you mentioned this in your book, Spotify has made no profit since it started in 2009. In fact, it's losing more every year. Other companies like Uber, Pinterest, Snapchat, Reddit, the list goes on. You show how these companies are not profitable either. If we were to look at the idea of VC funding, and this is also something this is a really powerful part in your book, and you were to analyze, like, does VC funding work at a basic profit level? What would you say?
Well, the numbers say it doesn't as an asset class, if you want. It doesn't mean it shouldn't exist, because there's a place for VC funding. But as an asset class, it's not generating returns that are superior to the standard, return you would get from investing on, an index fund. You will see that sometimes people point to, like, they will tell you, look at the top 25, percentile of returns, the top 25 percentile of funds. And this is amazing. Look how much money they're making, right? But there's selection bias because you first select the top funds, right? And then obviously if you select the top 25% people, the top taller people in a room, right? They're going to be tall on average, right? Because you selected the taller people. So you kind of need to look at all returns. You need to look at the entire asset class because you can't know in advance, if a fund will be at the top. And some people have studied persistence of performance to see if, perhaps funds at the top, they find themselves repeatedly at the top because they're generally better funds and they know how to invest money and select companies. And what they found is that there's a little bit of persistence, but very little, right? So the chances of a fund that was at the top 25% of also being at the top 25% in the next round of investment it's about 33%. So if it were random, it would be 25%. So it's a bit higher, 33%, right? And some people even say it's not even because they know how to select startups. It's also because they have better access to deals, potentially, because you become famous when you're at the top. So what I can tell you is that it's very difficult. There's a lot of private data, right, you can't have access to, but it's definitely not a very conclusive case for VC as an asset class. The evidence doesn't say, yeah, this is really performs really well.
And that's just one of these pretty plain things that you put out there that's actually pretty provocative, standing against the norm and not being the hype man. Once you just take a step back, you realize that, hey, this stuff, and that's kind of one of your main themes, is this stuff isn't as impressive as people have been saying. Now, anybody who's interested in this kind of financial aspect, Manuel talks a lot about this in Silicon, especially, well, the AI too, but you might want to check out Silicon for more of that. I kind of wanted to pivot to another part of the book, Emmanuel, where you talk about this weird phenomenon where people are being hired and they're not working at, let's say, I think you're especially talking about some of these big tech companies, and you talk about somebody who you said all she did was prepare a PowerPoint presentation every week. You talked about somebody else who was employed by an AI startup and only worked 15 minutes a day.
Yeah. That guy is still only working 15 minutes a day, like still today. Like I can assure you. Yeah.
Right. And then you have this story of a research scientist at Amazon who was hired for $300,000 and he ends up basically doing nothing. And then he finally works on something and has a little bit of interest in it. And then they basically tell him at the end, oh, that was just to satisfy some kind of terms of your performance plan or something. And that was actually cut from what they were doing. What the heck is going on with these big tech companies who have all these people? Like, it's an ambition of a whole generation of people to end up in Silicon Valley or Seattle area and get $300,000 a year and work at one of these big tech companies. But a lot of them seem to end up going there and they're not doing anything. Like, what's going on there?
Well, I think there are many reasons for that. The first thing we need to establish is that actually, happened and is still happening, but it happened a lot. And when I first started speaking about the fact that a lot of people didn't work in the technology industry, including me, I can tell you my story. But some people were skeptical, But then when Elon Musk fired 80% of the company and it's still running, some people said, well, maybe we were right that they weren't doing much, and there were massive layoffs everywhere. So how can you get away with, firing so many people? They're probably not doing much, or they're doing something very experimental, or kind of like out there project that you can just, do without. I was hired repeatedly to do nothing. I'm not a person who likes doing nothing, actually. I'm very active. And I decided to kind of leave the AI industry because of the hype. I was tired of everything being so overhyped and not working on real products, right? So I thought I'm going to go back to software engineering. I'll do more of the engineering side of things because it will be more tangible. And unfortunately, I landed on a few projects where there was absolutely nothing to do. Nobody worked. And we're talking, in one of these companies, I worked about 3 hours and 6 months, a total of 3 hours and 6 months. This was a very famous investment bank. And it's not like I didn't want to work. For the first 3 months, they put me on the bench. So officially, they told me, like, we don't know what we're going to do with you guys. There were a lot of us on the bench. And we were just paid to do nothing, but we had to sit around, right, and wait. The pattern, it's always the same. There's a lot of hype around something. We're going to build this tool. In this case, it was an AI tool. I was on the engineering side of things, but we would build a tool to support people who worked in AI within the company. Some manager up in the chain decided this is a good idea. AI is the next big thing. So let's hire how many people, and they consulted others. Okay, let's put together a team of 70. So they hire 70 people without really knowing what we would do. They didn't even know what the product would be. And they hadn't spoken with a potential user, which was quite surprising. So it's almost like they're hoarding people, right? Because first of all, they can. There was a lot of money at that time, as we said before, right? a lot of money in the field and a lot of hype, lots of promises. So you want the talent with you, and it happened to me a couple of times. And I decided it wasn't for me. I left that company voluntarily because I thought I can't keep waiting. I told them at the very end, because I realized I was super bored. I wasn't even going to the office anymore at one point because there was nothing to do. And they said, "What can we do to make it better? Maybe find me a different project within the company." And they found me a project. I said, "Okay, I'll speak with people who are working in the project before I make a decision." Right? I was like one step out, and these people they immediately told me they were working on improving this little product, but they knew it would never be used. They knew it would be scrapped in 2 or 3 months.
Wow.
But
Wow.
if they didn't improve it, they had nothing to do, right? And this is what made me write my book Silicon, because it was not just to investigate startups. I had the feeling that there's two options in the tech world. Either you don't work and you pretend you work, or you work for a startup where you build a product that nobody will ever use. There's other options. Some people do work very hard, and that exists. But there's a lot of the other stuff. And I looked around, and most of my friends were in the same situation, right? People who were paid a lot, but they weren't doing much. And one of my friends, he had 2 jobs at the same time, and at one point he had 3 as a secret, right? So his employers didn't know he had another job, and I think he's still doing it actually years later. So I thought that this is not sustainable. This can't last, and it didn't, because a lot of people lost their jobs. But I saw a few problems. In addition to the amount of money into the field, also all these methodologies that became very, very popular, like this agile thing. I think the principles of agile are pretty good. You need to adapt. You need to very quickly react to what your customers want. But a lot of people just adopted a recipe to become compliant to agile. Like, let's implement this Scrum thing where every task needs to be weighed or weighted. You need to give a weight, and people will vote on your task. So there's a lot of meta work. You talk about work, and every little task needs to be predicted. They want to add predictability to software, which is very hard. So whatever you do, you need to say, how long is this going to take me? And that's why people also exaggerate a lot, because they want to meet their goals. So everybody will say, it takes 5 times longer than it does, just in case. So there's been a series of problems, I think, that made this happen. And there's another thing I can tell you about this. Technologists who are in this situation, they're miserable. You can't imagine the number of people that have reached out to me to tell me their stories of not working and getting paid a lot for it and being miserable. And that's something that you can't say it out loud, because people think you're privileged. Like, why are you complaining? But they're miserable because they don't go into this profession to do nothing. You're a nerd. You want to build stuff. Don't be waiting around. A lot of people feel like this is wrong, or they feel like a scam, and I think that it's probably a good thing that people feel bad about this. So yeah, that was one of my biggest, discoveries as I was, investigating for the book. Like, what's going on? Why are people, so idle? Where did this come from? And how can we make it better? Also,
All very interesting perspective for sure, and no doubt there's all sorts of explanations for this behind the scenes stuff. Ample money. A lot of these companies, it seems like a lot of these corporations, once they hit a certain size, they just become very risk averse, and everything has to be vetted and tested by a million potential customers before they could even sign off on some of these things. So I'm sure there's a lot at work, and your book unpacks that a lot. Let me just kind of sum up the book Silicon, then, and we'll move on to AI. Is there a reckoning? Is there a reckoning coming to this entire industry, do you think? And will it look like massive layoffs, let's say if the bubble bursts?
We've already had a bit of that, right? Since 2022. A lot of people have been laid off. Money is running low. Investment is a lot lower. I think 2022 was half compared to the year before. So it was 50% down, and then another 50% the day after. I haven't checked the figures for 2024 now that the year has ended to see what happened. But I hear that money is not as abundant as it used to be, right? So that's one thing. A lot of people have lost their jobs. I think with the AI bubble is kind of making this last a bit longer. I think there was an article, I think, on the New York Times, someone saying this is like the last desperate attempt of the industry. right? That's what they're so excited about AI, because if it weren't for AI, it would be very, very disappointing. I think there will be a reckoning within the AI industry anyway, because the biggest disappointment with AI will be there will be, it won't be so successful in terms of business. So not so many businesses are going to make so much money or increase productivity so much from AI, right? And that will be disappointing, I think. So that will definitely be a reckoning.
Well, then let's move on to the disappointments of artificial intelligence. Then, so your book in this category is called "Smart Until It's Dumb: Why Artificial Intelligence Keeps Making Epic Mistakes and Why the AI Bubble Will Burst." You also have a book, it seems, you wrote for entrepreneurs who are trying to get into AI and they want a nice and sober approach to the very limited the limited benefits of AI. Let's start with the product itself then, and show that AI is not all it's cracked up to be. So you say that in your book, if you speak to AI fanatics, you'll see that some refuse to acknowledge that the problem at the root of epic fails is that AI isn't all that smart. Instead, they blame it on something else. The most popular scapegoat is data. They say that data wasn't abundant enough or adequate for the task. And then you also conclude by saying, in order to reach artificial general intelligence, someone would need to discover a new, unprecedented methodology, since machine learning, as it is today, falls short. So that's quite the takedown. But anyone who has used AI will see that it has some problems. Hallucination, for example, is one phenomenon. I show in our course, our AI anti-technocracy course. I'm hosting the local AI, and I ask it, hey, what's the first paragraph of James Joyce's Ulysses, this famous novel? And then so it gives me the first sentence. I'm like, okay, that's right. And then the second and the third sentence are in the same style, but it's completely wrong. And I'm like, wait, what? What the heck? Not only is it stupid in that case, and to be fair, that's a low parameter model that I'm hosting locally, but in that case it's stupid, and that could also be dangerous depending what you're asking. So maybe the big question is, why is AI so stupid when it's supposed to be so smart in certain instances, and is otherwise pretty clever at other things?
Yeah, well, I don't think it's that stupid. I think the capabilities of AI are very impressive as of late. But the problem remains the same. It's literally the phrase you read from my book. I stand by that today. It's the same situation. AI learns by repetition now, right? Machine learning learns by repetition and by example. So you take lots of examples. For example, you would take footage of a person driving a car paired with labels of what the person did. So you would say the person decided to turn left or steer left. And you create a system that tries to find patterns in data to try to predict what this person would do, right? And that's what you use afterward to have a car drive itself. So it learns from examples. And in the case of LLMs, of large language models, the task is to predict the next word in text based on text collected from the internet, right? That's the only task that LLM is designed to do. Then it's a bit of an illusion because you use the LLM to consume its own outputs to produce more text. But at the end of the day, the machine, all it does, or what it's designed to do, is predict the next word. And predicting the next word is actually quite powerful, more than it seems, because if I tell you, how much is 2 plus 3, predicting the next word, you kind of need to do maths for that. But the system is learned from text collected from the internet. So whenever there are situations that don't happen too often, and this applies to self-driving cars, it applies to LLMs, it applies to all AI right now, things that are in this long tail, as people call it, things that happen very rarely but are very important, and there are lots of them, AI doesn't really know what to do because it hasn't seen examples of that. And humans are very good, at coping with those situations. There are a number of explanations for it, and it's still up for debate. Why are we so good at that? But whenever the machine encounters something it has never seen in the data, or it's too different from the data, and it's rare, it ends up hallucinating, right? And another example, there was this car, self-driving car, that hit a truck that was towing another car, but it was towing it in a weird way. The car that was being towed had been attached in a strange way. So the self-driving car didn't recognize the situation because it was too uncommon. It was not in the data, right? And when you look at what the company said, I don't remember if it was Waymo or Cruise now, but the manufacturer, it kind of blamed it on the data, right? It's like, oh, the car wasn't being towed the right way, right? But a human can tell, right? We can tell that's a car. I'm not going to hit it, right? 10 minutes later, another car hit the same tow truck, another self-driving car we're talking about. So we have a methodological issue here, right? We don't really know how to create a system that will still be able to interpret very, very uncommon situations, right? And that's why AI surprises us with really silly mistakes once in a while that we didn't expect. The other day, I shared something on LinkedIn of, you can't generate images. If you use ChatGPT, you can't generate images of a clock showing any time other than 10 past 10. You ask it, show me a clock, of, draw a clock at throwing 3 p.m. It won't do that. And that's because almost all pictures of clocks online, they showed 10 past 10. And that's because it looks kind of like a happy face. So that's how clock sellers, they like to show clocks. But who would have expected that kind of mistake, if you want, a hallucination of telling you, because it generates a picture that says this is 3 p.m., but it's not, right? So we can call that a hallucination. Nobody knows how to fix this. And that's one of the points I made in that sentence that you read from my book. When there's a methodology, that's missing, you can't predict when it will be discovered. You can't do that because nobody knows how to do it. It's very different from an incremental change or doing something you know how to do, right? If you say, I'm going to build a bridge, you know how to build a bridge, you can calculate more or less how long it's going to take. Even then there's delays with that kind of stuff. But whenever you need a new methodology, which is what we need for AGI, you can't predict it. And another example of that is nuclear fusion based power. They've been telling us for decades, it's around the corner, but nobody knows how to do it, and you can search, but there's no guarantees that you will find, right? And my take on why AI is sometimes so dumb, there's this thing missing, coping with, strange scenarios, uncommon scenarios, and nobody really knows how to fix it. So I don't expect an improvement anytime soon. It's not like a little bug that it will be fixed because we know how to fix it. We really, really don't.
Very insightful at getting to the heart of AI in its current popular form, which is this pattern recognition, as you talk about. And one of the big differences you make between, let's say, human intelligence and machine intelligence is you use the example, well, the parents could point out to the new child who doesn't understand the word butterfly, they could point to the butterfly and say, hey, that's a butterfly. And immediately that child will potentially know what that is. Whereas with a machine, it could take thousands of butterflies, and still, even after that, the butterfly might be in a weird position. It might be behind an object. There's all these weird things that could throw it off.
There's this example of a cow on the beach, and the system didn't recognize the cow on the beach because it learned that the cow plus the grass underneath the cow, that's what the cow was, because the cow was almost always standing on grass.
So these data sets are kind of the way of doing AI right now. They determine a lot. And, we're talking about thousands and millions and large amounts of examples that, the AI is learning on. And not just learning, but you, in many cases, have to have somebody showing, like an actual human signing off and saying, okay, yes, this has identified this correctly. So there's actually manual labeling that's behind, and that's slow. It maybe inserts human error and subjectivity. Also wildly inefficient. Maybe you could kind of talk about that aspect of AI and how that's holding things back.
So definitely, we humans will learn in a different way. We don't understand that fully, but there's a book called, I think, How We Learn. And that's where I borrow that example from. The book explains many ways in which they're like meta learning techniques. Like we are born apparently with strategies to learn. Like, for example, learning through a process of elimination, it seems that we are born with that. This thing of a parent pointing to a certain object, right? There's a cue there, right? That the baby can use. They seem to be somehow born, they don't think it's the sky what the parent is pointing to. They see this smaller moving object. But the point here is that humans learn in a different way. So we don't learn just by seeing examples of how to do a certain job. We also use other strategies. I don't know if we can imitate them with computers or not. We're definitely not doing exactly that, with machine learning right now. And that's the point, right? We just operate in a different way. We learn in a different way, and that's what's missing also in AI, right? But if you want to know, so right now LLMs are trained in two phases, right? So the first phase is you gather a lot of data from the internet and you try to predict the next word. That was how it was done up to GPT-3. And then one of the novelty around ChatGPT and how they made it better was that there's a second phase of learning in which a human is actually in charge of labeling stuff, right? So they create examples manually of good responses and bad responses. And that's fed back into the LLM to fine tune it. So we can compare that a little bit with a parent, right? You got all these people, and they've said it's been people hired in Kenya for $2 an hour to go through thousands of sentences and sort them based on their quality, and do all that sort of stuff. And that's how they refine LLMs now. A lot of people complain about LLMs doing something really weird, right? And then it gets fixed. But how does it get fixed? It gets fixed from manually feeding data to the system. But how do you do with the long tail? Again, right? Because you can improve common causes of failure, but what about all those other things that you haven't covered? But that's interesting because I think, we need to acknowledge that there's a lot of manual work right now involved in fine-tuning these LLMs.
Yeah, definitely. A lot of interesting things behind the scenes going on. Now, and you have this good line too. You say the current systems of AI are in essence glorified pattern matching machines rather than intelligent visual learners. You also have this interesting section. You talked about how in the case of the Waymo or whatever AI self-driving car, it saw something it didn't recognize and it messed up. That means that AI, another way to think about this kind of antagonistically, is that AI can be tricked. And you talk about an example of people who basically can slightly modify, let's say, pictures or visual objects. And a human will recognize this and say, "Oh, that's obviously still a turtle," but the AI will be thrown off by it. So, what exactly is going on? And maybe if you're willing to say, like, how could you yourself potentially, let's say you were, privacy focused or something, let's say modify a photo or something like this to throw the AI off?
So people have reversed engineered, if you want, these models. So they take a model that exists. So and when I say model, it's a piece of software, right, that does the AI stuff. And they saw that you can see in which way could I alter pixels minimally in a picture, for example, in order to trick the AI to believe this object is something else, right? And they managed to do that with lots of objects and pictures and traffic signs. So you can alter a traffic sign so that to the human eye it still looks like a stop sign, right? But then the machine learning model will classify it as something else. And it's not just altering the pixels. They try that by pasting stickers on actual, traffic signs. And they also tried it with objects. So they say we have a 3D model of an object and we take a picture, right, of a turtle, for instance. And the model says this is a turtle, and they can use the model and some maths behind to try to see how can we reshape the turtle just a little bit so that the model thinks it's something else, right? And they've succeeded. It looks like a turtle to the naked eye, but then the machine thinks it's something else. I say thinks, obviously, to just expedite the explanation. It's not like it necessarily thinks. But what this tells us is that, again, very great pattern matching, what these machines do, but are they truly smart? They clearly don't operate the same way as we do if you can do that kind of trick, right? And from the privacy point of view, well, it depends on what you're up to. Like, what you don't want the AI to do what exactly, to potentially recognize what's in a picture that you post. What I can tell you about that is that it's still a bit tricky, because the way people have managed to do this, to trick the AI, is to take a specific model, right, specific piece of AI, and run an algorithm on top to see how can I modify this picture so that this specific model gets tricked. But that doesn't guarantee that another model will be tricked. And that's what makes things a little bit complicated, right? Because there are lots of models around, and there will be even a black market of models potentially, right? And they're open source models. So I think you're up for a big challenge if you want to be able to, let's say, prevent an AI from analyzing your picture. You may prevent a specific one, but probably not all of it.
Okay, let's understand AI a little bit more and what happens. What I show off in our course, and just this was a big eye opening moment for me. Locally hosting an AI. Okay, so I download this model of AI. Let's say in this case it's 5 GB. Okay, so that's a pretty low parameter one. I download this on my computer. I turn off my internet connection entirely, so there's no internet access. Everything about that AI is within that 5 GB, and I query this AI about all sorts of things, random events that Wikipedia has within it, random other things, and it has in many cases the answer to this. Now, I mentioned it's not really good sometimes at exactly quoting from books, but that could change and that depends on the model. But it answers a whole lot of questions, right? Medical questions, et cetera, et cetera. And it seems like it has hundreds of gigabytes worth of information, but it's all within 5 GB that is not at all accessing the internet. How in the world can we explain that?
I don't know the number of parameters in the model. I'm quite impressed, by what these models do. I mean, if it's a small model, it probably will not be able to verbatim quote text because it wouldn't be able to memorize it. It doesn't fit. But so one thing that's interesting about AI in general is that the way it works right now is that we design our models so that they solve the task in a very, very specific and tailor-made way, right? And that's why they can be made quite small, right? So there was a period of time, decades ago, where people thought that a very general model, very gigantic model, a neural network, as it was called, that was the way to go for AI. We will let the computer learn whatever it wants, right? Instead of doing that, the way progress was made was by constraining the computer to do things in a certain way. One example is with images. So the way it works for image recognition, to categorize an image, is that the practitioner, the person who creates the system, they decide to apply, let's say, filters to images. They say you need to apply, this many filters, and then you combine the filters. And the system can choose which filters to apply, let's say, but the filters are combined. But there's a very prescriptive process. It's not like the computer can do whatever it wants. It really needs to apply filters to create, if you want, derivative images from the original image. And then those filters are, again, combined, and there's different hierarchies of filters. I'm not going to go into the details, but we tell the computer how to solve the problem. And then the computer, through the learning process, can determine some details, right? The way it works with text, with LLMs, is that you want to disambiguate words, right? And the system specifically is designed to try to find which word in the piece of text is related to which other word. And that's used to disambiguate words. So there's a whole process. And that's why the system is smaller than one would imagine to cover everything, right? Because you can have, in order to disambiguate a word, you can use topics found previously in the text. You don't need to know all the details, right? If sometimes I give the example of the word bark, which means the sound made by a dog or the bark of a tree, the coating of a tree. Depending on anything speaking about dogs or animals in the text will help you find out without and that's why they can make those systems quite small, but they are impressive. You're still impressive. If you want to know more about the details, maybe you can go and look at the vectors that are used, the embedding vectors, and see how many dimensions they have. That's a big part of the trick. You can think of dimensions as all the topics that the system can learn. So it's fascinating, but I don't know exactly what you wanted to ask you. Is it magical, that we can fit so much information? I think it's very impressive. It's very impressive. It's counterintuitive that we can fit so much into that. But I think it's also because we found a clever trick, to disambiguate words, to understand the meaning of text without actually having to represent that much data.
Fascinating stuff. Of course, we have the cypherpunk ethos here, so we immediately take these, download them for ourselves, talk about how to use them as your own tools, like for prepping reasons and things of the sort. Let's say if the internet were to shut down. So that's kind of our philosophy here. Now, Emmanuel, I don't assume that you know all things about all AI related things, but I did want to just try to run this one by you. So Nvidia, the graphics card company who's behind AI, now they still make graphics cards for video games, right? That's still part of their business. And they recently, I was watching the announcement of their new line of graphics cards, the 5,000 level Nvidia series, and they are continuing to promote this technology called DLSS, which is called deep learning super sampling. What happens is it's when you turn it on your graphics card, it's a way. It sounds like maybe you're not familiar, but I'll just throw this out here anyway. It's basically my understanding. I was going to ask you why I shouldn't be explaining this myself. Is that they can generate frames that are AI generated. So it didn't actually occur within the game or something, but they're able to generate frames that kind of fit in between two frames. So it increases your frame rate in an AI generated way so that you can run more frames on that particular game while actually in reality using fewer resources or something like this.
So I know nothing about that, but I have been involved in the past, with kind of interpolation or restoration of images and stuff like that. So I can imagine where it's coming from, because indeed you can imagine using AI to fill in missing data, right? So you could say, how do I interpolate between two frames? How do I create a new frame, right? And there's a part of it is very simple, very systematic, right? You could kind of guess, but also there's a semantic component, because depending on the typical objects you find in life, like an apple, let's say, you know what an apple looks like, and you've seen it before, and you can interpolate better when you know what things look like. But I can totally see this being a use case of AI, of improving the quality. I mean, it's been used to improve the quality of images. It's been used to fill in some missing data.
Now that I'm reading the Wikipedia page, it looks like it's all about upscaling.
Upscaling. Yeah, I think there's potential in that. One thing I can tell you about upscaling and all of this, again, there's a semantic component, because if your images are common enough, there will be a memory in this system of what an apple looks like. And that's why I can upscale and upsample an apple. You're not going to be able to upsample equally well something that has never been seen by the system potentially. But yeah, I think this is definitely a potential use case for AI. Also, another thing, AI cannot really come up with new information magically. And I'm telling you this because sometimes there are misconceptions about this, right? If there is literally no way to guess, what could be between two frames, AI will not be able to come up with it. This sounds obvious, but believe me, it's not. And I can share an example of people thinking that when we don't have enough data to train machine learning, let's just create synthetic data using an algorithm. And that's really not the way it works, right? Because, I mean, if you had this power to create this data, you probably would have solved the problem in the first place. You need to usually go and gather real data, right? To train a system. Consider the case of self-driving cars. If you want more data for all those awkward things that could happen, like this car being towed in a weird way, you need a model to generate the data. So if you haven't considered the possibility of a car being towed in an uncommon way, then that won't be generated. So you won't be coming up with totally new data. I've also seen it with fraud. With detecting fraud in bank transactions. They're not many, luckily, in your data set. It's mostly legit transactions. So why don't we just use a computer to generate fake transactions? Well, but not just fake transactions from the existing ones. They say we just combine the existing ones to create new, fraudulent transactions. But that really doesn't work, because you can't just invent new stuff from existing stuff. So what I would say with this kind of thing is, like, I can imagine potential in improving frames or making them looking better, but there's a limit, to what the system was designed to do. Because sometimes we may get this impression that you can just create data out of the blue. Or I've seen that, in the movies, when you have some CCTV camera and there's a completely blurred image of a license plate, and then it is magically restored to the right license plate. That can't really be done, because that information has been destroyed. So if you can tell it's a 5, but it's blurry, then the computer could make it look like a better 5. But if you can't tell it's a 5, it's not going to come up with it, right? And I think this is maybe something I could say about the system. Like I could see how it could be used to improve stuff, but I wouldn't take it as a magical thing that can come up with new, new frames out of the blue. I would see it as an enhancement, I would say.
Your way of thinking reminds me of mine, which is to look at a lot of the hype and say, wait a second, look, there's something here, but let's not, like, for example, the Bitcoiners, there's something here. Let's not say this is going to completely change our relation to humanity and all these exaggerated things. That doesn't do you any, it doesn't do you any credit. And kind of on that topic, the main, I guess, the main idea of your book is just showing some of the exaggeration, the silliness surrounding AI. You mentioned a businessman who wanted your help in using AI for his business, just basically so that he could be seen using AI. What are some ways that AI is used, marketed, maybe some of the ridiculous aspects of this that you see that really isn't doing anything fundamentally when you get down to it?
I mean, I guess you can see all of these startups that are building AI products. I think everyone has forgotten about customers. I feel like with AI, customers, we just don't think about them. And in reality, a business is sustainable when you serve a customer, right? I heard a story of there was a company thinking of using AI to speak with your pets, not even speak with your pets, to kind of interpret what your pet was trying to tell you. I mean, it sounds a bit ridiculous, but you know why it was such a bad idea? I spoke with a strategy consultant who helped this company map out and analyze the industry actually in a very serious way, the potential of this idea. But it seemed that pet owners, they believe they already understand their pets. So, for example, if the dog is hungry, you already know if your dog is hungry. You know your dog. That's kind of that was the response from the customers, right? So it didn't really seem that it would add much value to have an AI say, oh, your dog, our data kind of shows that your dog is hungry, right? Another very interesting example, I think, is Amazon Fresh. The shop where you just walk in and you have cameras all over the ceiling and they film you. And then allegedly an AI will detect what you bought and send you the receipt automatically. You log in with your app.
Believe me, I have no experience of those.
Because of all your privacy. Yes, I can imagine. I live, close to there. I live in London. There are quite a few, so I've been to one a few times, and you just walk out of the shop and you get the receipt. There are two things I can tell you about that. Going back to a previous topic, I immediately, when someone told me about this shop, I thought it wasn't possible. So this cannot be built. AI can't do this, right? And that was because of the long tail. It was the same problem. I thought AI can recognize situations, but what if I grab something from a shelf, I give it to a friend, and then my friend puts it in the bag, and then he gives me the bag, and then I walk out with the bag. It's such a complicated situation to interpret. You will have no data for everything that could happen. And again, AI learns by repetition, by example. So I thought there will be too many edge cases that AI will not cover. And the first time I went into the shop, I thought maybe I'll be proven wrong now. But then when I walked out and I got a message saying, we're preparing your receipt, it will be ready soon. And it took 5 hours. I thought, this is fake. This is a human preparing my receipt. This is not AI. And that was the case, right? That it came out afterward that they had about 1,000 people watching videos and preparing their receipts. But that's beside the point. The reason I was telling you this story is that what I thought first when I heard this story, in addition to how it was probably not going to work, was what problem are they solving for customers? Why do we need to get rid of the checkout? In London, most supermarkets have an automated checkout machine. There's never lines or queues. Because of all the machines they've set up everywhere. So you can just walk out and you just need to scan your stuff, but there's no waiting, right? I thought, are people so bothered by the checkout process that they will flock to the supermarket because it's so cool? Or maybe they could reduce the cost, and make it cheaper because the store has fewer employees, but that wasn't true. Right? Because they still needed people to replenish the shelves. They have a security guard. They even have a person to actually explain the technology at the door because people don't get it. It's the first time you go to the shop and you're just completely, thrown off. You're like, well, what do you mean? I don't need to check out what's going on. So basically same number of employees. So my big question about that is, what are they doing for customers? And I think this is one of the biggest issues with the technology industry in general, but also with AI specifically. Think of your customer first. What problem are you solving, right? And I think with Amazon, they actually didn't think. And if you look at the story behind, it seems that they developed similar technology for their warehouses, for Amazon warehouses, and they try to push it somewhere else to see what else can we do with this. So it's the other way around. It's putting the cart before the horse, right? We want to use this fancy technology for something. You mentioned that example of this. There was this company, it was an accounting company. They're building accounting software and they want to use ChatGPT for something. And they reached out to me to see what that thing could be. And I'm like, okay, why do you want to use ChatGPT for something? Because we're raising money from investors. Now we can't tell them we're not using it for something. So to me, it's always technology first, AI first, and they forget about the customer, which is, at the end of the day, that's how you pay the bills with your business, right?
Very, very intriguing. And if you want to kind of get to Emmanuel's conclusion, I'll just say, hey, go check out his book. He thinks that we're headed for a mild AI winter and that people need to be more realistic. But I'll have people go check out your book to hear the rest of the story. Now, just wanted to kind of move towards the ending here, Emmanuel, and I wonder if you'd be willing for a few rapid fire questions. Overall, best LLM, what would that be?
I mean, I would say it's the GPT family. I think that's the one that's at the forefront.
Okay. What about an underrated LLM or AI tool that more people should be looking into?
Well, there's the DeepL for translation, which I think a lot of people just go to Google Translate, and it's a lot worse than DeepL.
How much time, you can kind of answer this as like a proportion, how much time would you spend searching for an answer to a question that you have on Reddit versus AI?
I almost always, it's like 99%, my questions are answered via Google search or Reddit. I don't use AI that way. I use it sometimes, but it's not usually to go and search for information because I still need to double check it anyway. So
Exactly. And this another thing you talk about in your book. What are a few of your favorite movies about AI?
I did enjoy watching Ex Machina.
Yes, recommend. Have you seen Upgrade from 2018?
No, believe it or not, I don't usually watch sci-fi movies. That's why I don't know how to answer this question.
What about favorite books on AI?
I mean, my book is my favorite book on
Yep.
AI, written by other people. I'm just joking. Oh, I can tell you what my favorite book on AI is, actually. I don't know if it's AI, though. But yeah, one of my favorite books on the matter are the ones by Roger Penrose. Books about AI. Oh, another one is by David Chalmers. It's called Philosophy of the Mind or something like about, I forgot the exact name. It's his most famous book about the philosophy of the mind. But it has a lot to do with AI. And it's a fascinating read, and it's an academic book that is accessible to everyone. I was not an expert on that, and I learned a lot. So I would say The Conscious Mind. I think it's called The Conscious Mind.
Last rapid fire. 10 years from now, will Nvidia still be the most valuable company in the world?
Oh, I mean, I don't think I can predict the future, but I would say no.
Okay, just a few big picture questions then, because you'd certainly have a philosophical aptitude. What exactly does digital mean, and are digital things capable of acting like human brains?
Wow. Well, two very different questions. The first one is very easy to answer because it's very technical. So very simple. Digital is when you represent information through a finite number of digits, states, right? Computers represent everything with ones and zeros, right? So it's not a continuous value that you could take, right? A number is always represented by a few digits, and that makes it digital. The reason we use zeros and ones in computers is that they're very easy to distinguish, right? So you have two states, low voltage, high voltage, very easy to tell them apart, right? And that's why, yeah, a finite number of states. That's what makes it digital. Your second question, can you say it again?
Based then on our understanding of digital things, can something digital act like a human brain?
That's a very good question because look, I think that there's still a lot of debate around it, right? Roger Penrose, who I mentioned earlier, he thinks not. He thinks our brains do stuff that cannot be imitated by a digital computer. So there's something special about the operations inside our brain, right? And this leads you down a very interesting rabbit hole, which is what on earth could our brains do at a physical level that a computer cannot imitate with enough precision, right? Because a lot of people say all physics is computable. You can just use a computer to calculate stuff. So I think there's an ongoing debate around this. I like to acknowledge that the debate exists because a lot of people very quickly, they will say, oh, our brains are just like computers. You can just simulate the physics. It's the same, right? And I would say, we could stop there. There's a lot of things we still don't understand. You look at quantum mechanics right now and the theory, very good at making predictions, but it doesn't make a lot of sense in terms of how it explains reality. So my intuition tells me that there is something special about our minds that computers can do. That's my intuition, that there's something else in there. And that's what Roger Penrose says also, that he thinks there's something special. He doesn't know exactly what it is. When you look at the evidence, people have tried to model neurons. We still don't really know how neurons operate. They have mapped out the brain of a worm called C. elegans that has like 300 neurons, and they haven't been able to predict the behavior of the worm because there are so many things that we still don't know. We don't know what neuromodulators do. We don't know exactly what equation, each neuron performs. Nobody really understands brains. We don't understand anesthesia. Nobody knows how anesthesia works. We know it works. We know it turns your consciousness off. We don't really know how it works. So I think there's so many unknowns, and it's very difficult to have any definite answer because a lot of it is philosophical, right? And you can't really know if any other being is conscious. I think it's a fascinating debate, and I learned a lot from a lot of people, and that's why in my book, Smart Until It's Dumb, I have a chapter on the mind, and I've kind of told all versions of this story. But it kind of computer act like a human, is it act, can they to the outside world do the same as a human? Well, if you look at ChatGPT, it can be very convincing in the answers it gives, but then also it hallucinates once in a while, right? So you go and poke and poke and poke, and it gives you really credible answers, and then it doesn't, and then you're like, oh my god, this is so silly. It can't draw a clock,
Right.
at 3 p.m. Right? So you definitely cannot act like a human. So I feel like when that happens, it almost reminds you that this is still a machine that doesn't behave like us, and then internally, do these machines feel, or do they have feelings? That's another, very, very philosophical question. I don't know if I have an answer, but what I can say is that I think the debate is fascinating, and we need to acknowledge the different opinions, because a lot of people are very quick to say, oh, we are obviously computers. Yeah, maybe neural networks don't work exactly like as in artificial neural networks don't work exactly like neural networks, but it's just a matter of changing the equation a little bit. And I'm like, I don't know. I don't know if that's true.
Well, that's definitely the question to end on. Thank you again, Emmanuel Maggiori, author of three books. One of them on kind of big tech, two of them on AI. They're available on Amazon. He has a website as well. We'll have all of the links. Maybe he could do consulting for your company. I'm not sure. I'll give you the final thoughts and where people can find you.
Yeah, I mean, people, they can find me on my website. They can just type in my name. I'm also on LinkedIn. That's where I post stuff. So they can add me on LinkedIn. I'm always happy when people reach out. Always happy to answer questions. And a final thought. What could be a final thought? I think that we need to focus on boring stuff again. There's a lot of stuff that is so boring and is so necessary and is actually very exciting, because you see that airports operating so inefficiently using paper, like paper forms. That's how it works today. They keep all aircraft maintenance records on paper. There's so many things that, everyone's speaking about AI, but so many industries need a lot of help from technology potentially, and it's not sexy enough. So it's almost like, who wants to do that? And actually, the most successful or predictably successful people I've met, they've helped a boring industry solve a real problem. And they were very happy to help them, and they made money. They didn't become billionaires, but they did become millionaires. And And I think, let's go back to boring stuff instead of the shiny, hyped up thing.
Hey, thanks for listening. Look, I could use your help real quick. If you could share this, engage with me in some way, leave a review anywhere. This really helps me to break the technocratic shadow banning that is happening with my brand. And of course, if you really want to escape the technocracy, go to escapethetechnocracy.com. Privacy tutorial series, books, consulting, and of course, you can leave a donation. Thank you very much.